We are going to be working with the graphing aspect. Notes time. In our normal what we normally draw on when we're drawing graphing something is called a Cartesian plane. It has, the proper name is the Cartesian plane. We work with it. We've worked with it many, many, many times. It's where you have your x and your y axes, and you are very, very familiar on how to graph something like 2, 3. You go over 2, up 3, put a dot, yes? No worries, no scariness there. However, the name Cartesian plane often kind of throws people for a loop because that's its proper name. So what we're going to do is we're going to go from what we call a Cartesian plane into something called an Argand diagram. Your Argand diagram, so it'll look really, really familiar. Your Cartesian is broken down into an x and a y, where your Argand diagram is going to be working with a complex number. Bless you.
Thank you.
You're welcome. So the real axis is what we know as the x-axis. Your imaginary axis is what we know as the y-axis. So if I asked you to draw 2 plus 3i, you're going to go over 2 on the reals and up 3 on the imaginary, and there you have it on your Argand diagram. And it's kind of like, but not the same as a vector. So your starting point in this case was 0, 0, and we did go up to the 2 plus 3i. Kind of like a vector, however, no arrow on the end saying it's going to go in that direction. But the two things that we can do with an Argand diagram is we can figure out two things called, one is called the modulus, okay, and we're going to be able to find the argument. The modulus oftentimes is represented like we did on modulus back in the day. It's really the distance from your point 0 to your, in this case, 2 plus 3i. And so the way you do it is you take the square of each of the numbers, add them up, and then take the square root of that. Does this look familiar at all? What does that look like? The magnitude. Exactly right. So what is the modulus of 2 plus 3i? So we could call it z is equal to. So what is the modulus of z in this particular case?
So the modulus is like the distance or the length of it?
The length of it.
Okay.
Did I ever ask you to find it? Like, they'll never ask you to find the length of it, and they always say modulus.
Correct. Modulus. Yeah. Okay, so the argument is the angle that is made from the real axis to the actual line that you created. Okay, and the formula for it, and the way we talk, like this is how we ask to do it, it's these straight lines. To find the argument, we would find the arg of z. Arg, okay? And so it's tan of theta is equal to y divided by x. So in this particular case, it's a pretty easy one. And you want to be you want to be in radian mode. Always, okay? So this one's a pretty easy one because it's in the first quadrant. My y and my x are both positive. So this, in this case, it'd be tan theta is equivalent to, what is my y in this particular case? Any ideas? 3. And my x in this case? 2. Are you able, in radian mode in your calculator, able to find the argument? Okay. However, there's a bit of a trick. Occasionally we have to kind of figure out where we're located. So that one is, it is what it is. We were able to find it in the first quadrant. Now, I'm gonna give you 4 of them. We're gonna work on 4 of them. So the first guy is 5 plus 12i. Let me just write them all down. The second guy, leave space. We're going to graph each one of them. But leave yourself some space to do some work with them. All right, I'll let you draw each of those. A, for the first one, I'd like you to find the modulus and the argument of this guy, please. So for part A. Because you did the square root of 5 squared plus 12 squared, which is 25 plus 144, which is the square root of 169, which is 13. Perfect. How about your argument? Any questions, comments, concerns, issues about arguments? Yeah?
For the modulus, will it always come out to be a pretty number?
No. It would be nice.
It would
If it's
be.
not pretty, like, if it turned out to be the square root of 159, you would just leave it the square root of 159. Or if it was something like the square root of 160, you could break it down into the square root of 4 times what? Actually, 16 times 10. And so you could make this 4 square root of 10. You could break it down that way.
Okay.
It's not wrong if you don't.
Okay.
But, okay. All right, how do we do on the argument of that? You said 1.176? 1.176 is correct. All right, cool. Now, how does this change? First quadrant, easy to go, okay? Second, third, and fourth quadrant have a little bit of, you have to kind of work through the process. The modulus is always the same because you're squaring the numbers anyway, regardless of where they're located. So it's okay. So I'm gonna do it in a different color. The next guy is -3, 4, right? So -3 up 4. So go ahead and find your modulus for this one, and then we'll talk about how to find the argument. Yeah. So we are looking for theta. In the first one, we'll do it with black again. In the first one, our theta was going to be from the x-axis to that. All of them are actually from the x-axis to the spot at which we're located. So if I'm looking at this, so from the x-axis to the red line, do you agree it's the big angle that creates that? So if I'm not paying attention to this guy anymore, if I'm going from here to here, that's a large angle. Everybody okay with what I'm saying? However, we have, if I look at the numbers, I've got -3 and then up 4, right? So if I think of it that way, if I go about taking just the positive aspect of it, so if I take tan of theta, and what's my y in this case? Well, it's a 4, it's +4, right? If I take the positive, and I actually take the positive of this, and go ahead and find your theta for me, if you don't mind. So, 0.927. What that gives me is if I did the positive, so up 4 over 3, it would be this little version, which is comparable to this size here. But I need the big guys. So the answer we're gonna do is we're gonna take pi minus that answer. Because I don't want this small 0.927, I want the remainder of that. So if I'm in the first quadrant, it is what it is. If I'm in the second quadrant, I'm going to take pi minus the angle that I get. So my new theta is going to be pi, and they use alpha instead of theta twice. So they'll say, when we brought it over here, we're finding a little alpha, which is comparable to this. So it's pi minus that little alpha. So that's kind of the formula that you use every time to find the argument in the second quadrant. Okay? First quadrant, it is what it is. Second quadrant, you're going to do pi minus that.
What is the modulus for? Like, the purpose of it?
Modulus is how far from here to here. It's the length of it.
Okay.
Kind of like the hypotenuse of a triangle. Kind of think of it that way. Okay, so do me a favor. Find where C is located and find its modulus. Again, right? And from what I've told you so far, the angle here is how far it is for this quadrant, how far it is from the x-axis. The angle from here to here, we find the little alpha of it, but we know that it is how far it is from the x-axis. How do you think we go about doing this guy over here? Just by what you kind of think you know. So how far it is from the x-axis? Would you agree that would be in the negative direction? And that's probably a no-go, so I really want to know the positive of it. So how is this going to work? Good. What happens if I do over 12 up 5? So, over 12 up 5, right? So if I went over 12 up 5 and I found the angle for that, would it be comparable to this guy over here that was over 12 down 5? What would be the only difference? This would be the positive version of it, this would be the negative version of it. Do you guys agree? So if you found the positive version of it, you could just negate it and find your other angle. So the theta is going to be the negative alpha. So go ahead and take tan, we'll call it alpha, just so you have two different versions of it, is equal to the y over the x. So go ahead and plug that in. Equals 5 over 12. But we are remembering that our original is going down in that direction, right? So you could have taken a negative answer of this, or you could just say, look, I know it's comparable to that. It's going to be the positive version of it, because that's the angle that I'm looking for. So 0.395 is the actual angle that you're looking for. I always liken it to how far it is from X. If you put in this side, the negatives with it, you're gonna get negative 0.395, and you would just negate it. So you just want the positive version of that answer. Okay, and the last one is what? Over -4 down 3. So go ahead and give that one a whirl.
That would be negative.
It's actually the positive version of it, because I kind of did the positive version of it. You could do the negative of it.
But if they asked for the argument of like the negative, like the 12 minus 5i, what do you have to give?
You would give the positive, the actual answer of the argument of this here, of that argument, is going to be negative. Yes, you're right, the negative, because you're going down in the direction of negative. Sorry about that. So this one's positive, this is negative. I use the positive to get this one, but it is indeed negative. And what do you guys think about this one over here? How is that gonna work? So, I'm looking, do you guys agree, I'm looking for this big piece here, from there to there, right? But this piece is gonna be comparable to the size over here. So the actual value is going to be negative pi, because I'm going backwards, and then plus whatever alpha I find. So we're gonna do the tan inverse of 3/4. So what was it originally? -4 minus 3i. So tell me what you get when you do this, which is this guy up here, the small version of it.
Sorry, can you explain the drawing, like how you have the negative pi plus alpha?
Yeah, okay, so do you understand where this dot came from? So we are looking for from here to here.
Okay.
That's theta that we're looking for. So what I'm gonna do is I'm gonna make it the positive version. I'm gonna find how big this is, and that's the same size as this.
Oh, okay.
It just is where they're located. So that's the same size of it. And once I do that, I'm gonna take, because I'm going in the negative direction, I'm gonna take negative pi plus the answer that I get,
Okay.
which is gonna get rid of that point. So what do we get when we do tan inverse of 3/4?
0.64.
Okay, and then do negative pi plus that. 0.64 what?
4. -2.498.
Yes. And logically, does that make sense? What is pi equivalent to? 3.14, right? So from here to here would be negative 3.14. Right, so we know we're going in the negative direction. Is negative 2.498 makes sense? It's going in the correct direction, and it's bigger than pi over 2, smaller than 3.14. So, last year, the way they all did that was they actually did a little chart in their notes, that in the first quadrant, it's theta itself. In the second quadrant, you do this. In the third quadrant, you do negative pi plus the alpha, and then over here, you just negate your alpha, because you're going down in that direction. So let me give you one to try. U equals 6 minus 3i, give you that one, and then W equals -7 plus 5i. excuse me, find the modulus and argument of each one of those two guys there.